And so we're going to go over this. Let's make sure our devices are away. We're ready to go. And this lesson is pretty much reviewed. So if your computer is out, just put it in courtesy mode for right now. And you'll have time today and tomorrow to work on it. It's not due till Wednesday. All right, so what form is this first one? Does anyone remember what it's called?
Factored.
Yeah, factored form. So we need to know that that is in factored form, or we can also call it intercept form. Which one of these is easiest to get when it's in factored form? Not the vertex, the x-intercepts. Because remember, we just make the factors equal to 0 and solve. So y1 would be easiest to find the x-intercepts, because all you do is you take your factors and make them equal to 0. It's already factored for us. So what would your x-intercepts be? How would I get x by itself here? Add 3, and you get x equals 3. And what would I do here? Subtract 1, and you get x equals negative 1. So we know that our two x-intercepts are 3, 0, and negative 1, 0. So the easiest one to get your x-intercept is when it's already in factored form. We've been working on factoring so that we can get the x-intercepts. What about this middle one? What's this called? What type of form? You got it. Standard form. And so remember, that's when everything's on one side and it's like ax squared plus bx plus c. Which one of these is easiest to get when it's in standard form? Not the vertex. The y-intercept. The reason is because your y-intercept is just your constant. So what's your constant in that equation? Negative 3. So my y-intercept would be 0, negative 3. Or if you plugged in 0 for x, you would get the same thing. But standard form's easiest. We can get the axis symmetry of vertex because we did negative b over 2a, but that would take more work. Because this third one is in vertex form. That's why it's easiest to find the vertex, because it's already in vertex form. And so remember, our vertex, our x-coordinate's the opposite of what's in the parentheses. So what's our x-coordinate? Positive, right? Because it's the opposite. But the same as what's on the outside. So negative 4. Remember that? And so y3 is in vertex form. It's just the opposite of whatever's in here, but the same as this one. And so when I give you vertex form, I give you the equation a parentheses x minus h. That tells you minus h. It's the opposite of whatever you're doing. Does this make sense? They're all three the same equation. They're just written in a different form. So I want to make sure you can see which one's the easiest for which equation. So make sure this is all down on your paper. Circle how you felt about that. Maybe you just didn't understand directions, and now you understand. And we're going to get started with today's notes. And so today's notes are not anything new. It's almost just like a cheat sheet for you. So I created like a little cheat sheet. It's a white paper on your desk. But it's a cheat sheet of how to get each thing in each form. Like the easiest way to go about it. Does everyone have this down? Yeah. Cool. So we're going to get started on this. And so first, what form is this in right here? Standard. So write that down. This is in standard form. And we said something's the easiest to get when it's in standard form. What is it? The y-intercept. And so we know when it's in standard form, our y-intercept, we can just look at the c, right? The constant. So what is our constant here? 10, right? So we know our y-intercept is 0, 10. So when we're looking at our y-intercepts and it's in standard form, it's pretty easy. You just look at the c. You could also look at, I'm always going to say other ways too. You could also look in your calculator, right? Type in the equation and find, and you can find when your x is 0, whatever number your y is your y. Roots. So when we're finding our roots here, what are the different ways we can find our roots or our x-intercept when it's in standard form? the different ways we learned? What's that called? What's that? Factoring. We could factor and make our factors equal to 0. What else did we learn? What else did we learn? There's some formula. Negative b, that whole formula, the quadratic formula. And I'm not saying every time, but sometimes you can put it in your calculator, right? And it's when your y is 0. Whatever the number is, the x is your roots or your x-intercepts. So this is just kind of a cheat sheet. And we'll get our actual roots later. Axis of symmetry, how do we find that when it's in standard form? What's that equation we learned 2 classes ago? Negative something. Negative b. Good. Negative b over 2a. That's the easiest way to get your axis of symmetry. So this worksheet is like literally just summarizing what we did this unit. So I would make sure to write it down even if you feel like you remember it, because this is probably something that you should study and everything's together on one paper. Negative b over 2a, or we can put it in our calculator sometimes, and it's where that bump happens, right? So it's where the y's go from a number to a different number back to that same number. Cool. Vertex. So we already know we get our axis of symmetry by negative 2b over 2a. How do we get our y coordinate? What do we do with this coordinate right here? Whatever it is. Multiply or plug it in. So remember, once we get our answer for this, we plug it into the original equation. And we'll go over that at the bottom when we're turning it to standard form. It's already in standard form, that's why I put an X. Vertex form. So the easiest way to do this one, we learned how to move it over and complete the square, right? So you could do it that way, but the easier way would probably just be to do the negative b over 2a. So when we do that, what is our b here? Right here. Good, so it's the opposite, negative 7 over 2, and what's your a? 1. When you do that, you end up getting 7 over 2. And what is 7 divided by 2? 3.5. So do you guys see how it's a decimal? Because it's a decimal, it wouldn't show up in your calculator. And so I know when I write this, y equals x, and remember it's the opposite, so the minus 3.5 squared. And to get my y, I just plug it in. So I'm going to rewrite the original equation, but instead of x, I'm going to put parentheses. Squared minus 7x. And so instead of that, I'm going to put 3.5.
Is that the format?
Yeah, but this is just the original equation. I just, instead of x, I put parentheses, and I'm going to plug in this coordinate, whatever I got, so 3.5, to figure out what is my y coordinate. What do you guys end up getting? Beautiful, negative 2.25. And so my vertex would be 3.5, comma, negative 2.25. That wouldn't show up in your calculator because it has a decimal, so you do need to solve it like this. And remember, it's the same on the outside, so you can write it like that. So instead of doing that, completing the square where you move it over, you fill in the blank, do all that, you could also do it this way, where you just do negative b over 2a and plug in the opposite of x and y. Does that make sense? Or you can do completing square. Factoring is just when I write it out, right? X squared minus 7x plus 10. And I do my a, c, b. So what is 1 times 10? 10. 10 and it adds to negative 7. What two numbers multiplied to 10 adds negative 7? Negative 5, negative 2, ding, ding, ding. So you end up getting x minus 5, x minus 2. But we got to make them equal to 0. And so we know it's just the opposite. So what's our x here? What's the opposite of negative 5? 5. And the opposite of 2, negative 2? 2. So we know those are our two x-intercepts. 5 comma 0, 2 comma 0. So those are our roots. And so remember, when we do our test, you make sure you put a under. You are going to have to do that 2 times on your test. Where a is bigger than 1. Yeah. Yeah, so you could divide 1, but dividing by 1 is just that same number. So sometimes I skip over that, but I would do it every time because there are 2 under tests where it's not going to be 1. And you will have to go to do that. And so if you did the quadratic equation, right, you still do the same thing. Does that make sense? All right. So next one is vertex form. And so how you would find your roots is, we can remember what we learned last class where we took taking the square roots. Remember what we learned last class when we did the paper ball activity and solved for x? That gets you your roots. So if it's in vertex form, you could just plug 0 in for y and solve, and we'll do that in 2 minutes. So actually, we'll just do it now. So all we do is we write like this, but we make it equal to 0. So how do I get 9 to the other side? Add it. And you end up getting x plus 4 square equals 9. Now, how do I get rid of the square? Square root. And so remember, I end up getting x plus 4, and I have to write it twice, because what's the square root of 9?
30.
And negative 30. Then I just solve. What do I have to do to both sides? Get x by itself? Subtract 4. And you end up getting x equals negative 1 and x equals negative 7. Those are your two roots. So the easiest way to get your roots when it's in vertex form is to just plug in 0 for y and solve. The easiest way to get your y-intercepts is either use your calculator or convert to standard form. We'll do that in a second. All right, next one, axis of symmetry is just your opposite of h in your parentheses. So what is your axis of symmetry here? What's the opposite of negative 4? 4. Good. Vertex is just your opposite of h and k. So we know it would be 4. And what's the y coordinate? Up there. What's our k up here?
Oh, no.
Negative 9. Standard form, you are going to have to do one like this, and I didn't really teach this to you. This is a multiple choice question on your test. So I want to make sure you we know how to do that. And so all we do, so the equation is this, x minus, what was it? X minus 4 squared minus 9. And so see that x minus 4 squared right there? I need to figure out when I multiply that out what happens. So I need to do the box method like this. And so I write x minus 4, x minus 4. Because it's just x minus 4 twice. Or you could do FOIL, distributive property, doesn't matter how you do it. So I need to solve what x minus 4 squared is first. When I do that, I get x squared minus 4x plus 16. Is there anything that I can combine? Good. Negative 4x and negative 4x. What does that get me? Good. Minus 8x plus 16. And then the last thing I have to do is just subtract 9 at the end. What's 16 minus 9? Yeah. And so that's standard form. So you do the same thing every time. There is one question on your test like this, where you have to convert it from vertex to standard form. Remember, you could always put this in your table too and figure out which answer choice, because it's all multiple choice. Figure out which answer choice has the same table. You could always do it that way. So what's the y-intercept here? 7. So now we're able to see that it's 7. And then factored form, I would just take it from standard form and factor it. So we need to figure out what multiplies to 7, adds the negative 8. What would it be? Good. Negative 7 and negative 1. Ding, ding, ding. So I know it's x minus 7, x minus 1 equals 0. And remember, you can make them equal to 0, or you know, hey, it's just the opposite if x is 1. So I know x equals 7, x equals 1. Those are my roots. So this is just literally combining the entire unit that we learned in one piece of paper, so you only have to look at one piece of paper. Does that make sense? So this isn't anything new. But like, I'm not going to say, hey, for this question, if factored, that means the x. You would need to know, okay, if they're asking for something in factored form, that means I need to do the x. All right, last one. That's a lot. So this is in factored form. Well, first of all, this is in vertex. And then this last one is in factored form. And so remember, I just make my roots equal to 0. So make factors equal to 0. So. So I would take my roots and I just make them equal to 0. And what would I end up getting when I make them equal to 0? I would subtract 3, and you get x equals negative 3. So that's my first x-intercept. And I would add 5, and I get x equals 5. The y-intercept, we would need to either plug in 0 for x, so we can plug in 0 for x and solve, or convert to standard form. Axis of symmetry, we could put in our calculator, or convert to standard form and factor. Same with here. All right, so standard form, this was our first lesson. We did this before Thanksgiving. So what you're going to do, remember, you can do the box method just like we just did, distributive property or FOIL. And so my factors are x plus 3, x minus 5. And so I just multiply, what's x times x? 3 times x, negative 5 times x, and then negative 5 times 3. And then I just combine my like terms, and you end up getting x squared minus 2x. Please add, combine, minus 15. Vertex form, we can do completing the square. So maybe we want to go over that one more time. That's where I move it over. I know I'm talking a lot today, but I want to make sure you guys have these notes. So remember, we add the constant to both sides. And we get x squared minus 2x plus blank equals 15 plus blank. Then how do we get what goes in the blank? What do we do with that 2? Divide it by 2, and then what do we do? Good, and square it. So what's 2 divided by 2? Yeah, and then square it. 1. You take half of this number and square it. Every time. And then I would factor this, and you end up, remember, it's just x minus and whatever's in here. So 2 divided by 2 is 1. Equals 16 when I add this. How do I get 16 to the other side? Subtract it. Good. So this will be a question on your test too. And that's vertex form. So what's your axis of symmetry? When x equals 1, because it's the opposite, and your vertex is 1, negative 16. So that is an entire unit in one piece of paper.
So you divided 2, and you got 1.
And then square it. Or you could take negative 2 divided by 2 and it's negative 1, but then you can square it. And factory form we already have. So that was a lot. That was an entire unit. So it's